Hi, I'm going to share with you today my favorite types of rocks, and these are sedimentary rocks. Why are these my favorite types of rocks? You'll have to see. Here's an example that I found in Australia, and you can see these beautiful snail shells. Whoops, hold on. That's not the right thing. Move that over here. You can see these beautiful snail shells, like right here and right here. Also, these corals. That's neat. There's some fossils in this rock. Cool. Let me erase these guys. Okay, very cool. Alrighty, so I'm going to share with you some information about sedimentary rocks. There we go. Okay. All right. So, first of all, if I was giving this lecture in person, I would have the students meet up and try to stumble through writing definitions for these things. The point of this is just to realize, like, I have an idea of what this really means without even, having the professor tell me. So that's cool. So that was kind of my point of that. But I will give you some ideas. So you often hear weathering and erosion as a process that happens together, but I bet you don't really know the difference between those two things. So weathering has to do with a rock breaking down into smaller pieces. So this could be, in the case of fossils, it could even be like a piece of coral that gets chewed on by a fish and pooped out. It could be like a rock that's rolling down a river and little pieces are chipping off as it's rolling. But either way, somehow you're producing something called sediment. Ooh, look, that's one of our other words. So sediment. What is sediment? Sediment is just broken down pieces of rocks and minerals. Great. Then, what is erosion then? Because I thought weathering and erosion was the same thing. So it turns out erosion is when those particles are transported to a different area. Particles transported. So this could be by water, like sand being washed around on the beach, or sand and pebbles washing down a river, or it could be from ocean currents underwater. It could be from wind, like sand dunes in a desert. It could be from the sediment, and mud is an example, gets stuck in your shoe and then you fly in a plane to a new place. So all of those are examples of erosion, but generally we're talking about the natural rock cycle here. So we're going to stick with water and wind as being our big erosion contributors here. And deposition might be harder to define, but in the case of geology, deposition is when sediment is laid down. So it settles out of the water column into a layer on the bottom of a lake or the bottom of the ocean. Sediment can fall in between corals on a reef and become sediment on the bottom of the coral reef area. It could be that sediment gets blown into an area where it sits for a long time on a desert. So sediment is laid down and it stays in layers generally. So, I guess I need to erase these guys. Okay. Anyways, so sediment, unconsolidated material made of fragments of rocks and minerals. That's pretty good. So here's some examples. We've got some nice shells over here from the bottom of the sea. We've got some sand grains. This is kind of a close-up under a microscope of some sand. But I have some sand here from Fort Myers Beach, Florida in my bag. Very fine sand. I also have some shelly gravel material from the Florida Keys that has pieces of coral, pieces of snail shells, and things like that in it. So those are some examples of sediment. So I always like to start with that. Most people skip over it, but I study sediment. I love it. I like looking at it under the microscope and seeing what kind of tiny creatures were living. So types of sedimentary rocks that we're going to talk about today. Different books and different people kind of classify it differently. So the one that people usually think about and is very abundant on Earth is a clastic or detrital rock. These are fragments that were formed from chemical or mechanical weathering. Chemical weathering would be like from slightly acidic waters kind of breaking up a rock. Mechanical weathering would be what we were talking about, like a river rolling a rock or something rubbing against it and causing that to come off. So we'll look at some examples of those. Chemical includes biochemical and organic. So these are when dissolved minerals precipitate out of a solution. That sounds boring, but it can also be when dissolved minerals are used by a clam to make a shell or a coral. So lots of fossils are actually created in that way. So clastic sedimentary rock, this is an example where you see these layers of sand. So these layers were deposited, right, in an environment, maybe a lake or something. And then they got lithified, cemented together by tiny minerals. And a conglomerate and a breccia, these are coarse-grained examples. So you can see the scale bar here. They have little pebbles in them. So pebbles are bigger than sand. So that's a type of sediment that's considered coarse-grained. And here's a conglomerate. It has these nice big pebbles. And these are rounded. So a lot of times you can learn about the environment that these rocks were formed in based upon the types of grains that you have. So these rounded pebbles indicate that they were probably rolled in a river or rolled on the beach, rolled in water somehow to end up getting that rounded shape to the actual grains. And a breccia is usually something that formed really close to where it originally broke up. So a lot of times you can actually find breccias near volcanoes, which gets a little murky in terms of whether it's sedimentary or igneous. Okay, so here's some sandstone examples. I have another example here that has these nice layers. And shale, these are just showing the different colors of shale. Shale is made of mud-sized particles. In terms of geology, mud doesn't have to be watery and sticky, but mud is just really fine grains, fine enough that you can't really see the actual grains. I can see grains of sand, but I can't see grains of mud without a microscope. So here's an example of an environment, a depositional environment. This means an environment where the sediment would be laid down. So here you see a river. It has a lot of sediment around the edges of the river. So the sediment is being deposited here. A delta is a very common sedimentary or depositional environment. This is showing the Mississippi River Delta from a satellite. So the river comes south. You know, it goes by Illinois and all this, and it goes south into Louisiana, and then comes out in this long, strange shaped delta into the ocean. So this dark blue area out here is the deep ocean of the Gulf of Mexico. Here's these tiny clouds as shown from space. What is all this brown and green stuff? So it turns out this is mud that is coming out of the river, and it's floating in the ocean for a while before it sinks down. So sand and mud are being transported to the Gulf of Mexico. The Gulf of Mexico has tons of layers of this material. This is one reason there's a lot of oil and gas, because there's a lot of sediment, and oil and gas forms in these sedimentary rocks. So you can look on Google if you want to see Mississippi River Delta, but I just wanted to include the definition here. A delta forms where a river meets the sea. It could also be where a river or a creek meets a lake. But basically, some kind of water that's flowing, like a river or a creek, gets to an area where the water is more calm, like a big ocean or a big lake. So the sediment is deposited due to a decrease of water energy. So it's not being carried by the river anymore. And now the water energy is lower and it can settle and be deposited. Chemical sedimentary rocks are a bit more strange, in my opinion. Sediment can also be considered when the minerals are dissolved in the water. And then it can precipitate. So that means like forming crystals. So here's an example from a very salty lake. And you can see these strange rocks are covered with these white crystals. So the white crystals are made of halite, which is rock salt, or gypsum, which can make a rock. So these are two minerals that can form evaporites. So an evaporite is when you have a lot of evaporation coming out of the area, like the lake or the ocean. And so that means that the water has extra salts in it because the water is escaping as evaporation, but the lake water then has more salts and less water in it. So this is usually in a hot climate, a climate that doesn't have a lot of rain also, so a desert environment. One example is if you take a cup full of seawater and you just let it set for a long time, you'll end up getting these crystals all around the edge. This is calcium carbonate, CaCO3. This also contains a lot of salts. You know how salty the ocean tastes. It contains gypsum. It contains a lot of strange minerals. That's one reason the ocean water tastes so weird. It's not just salt, it's a lot of minerals actually. So this is creating a sedimentary rock right here. Another really interesting sedimentary rock that's chemical in origin is opal. And it turns out that opal forms underground from groundwater that has some really strange minerals in it. So then it can kind of fill in anything that's porous. So you can find opal, like the one in the bottom left here, is opal replacing all these shelly fossils. You can find opal kind of just forming in cavities that used to be cavities underground, like a geode. Or you can find opal that is actually filling in petrified wood or even filling in dinosaur bones. I've seen an entire opalized dinosaur fossil skeleton in a museum before. So opal is a very neat one. And then biological chemical rocks, of course, are usually formed from different types of fossils. That's why they're called biological. They're formed from biological things, something that used to be living. So limestone is my favorite rock. Yay! So limestone's my favorite rock because this is the one that has pretty much all the fossils in it. Here's some weird examples of fossils. You can get these really tiny ones. This is under a microscope called foraminifera. You can get a rock that's made of just pieces of shells. And so there's lots of different examples of limestones. So let's show you a couple others. So when we're looking at sediments that could create these types of limestones, I've actually studied sediments in a lot of different areas, including Fort Myers Beach right here in Florida. But one of my expeditions out to sea was in Southern Australia, and I got to use this huge grab sampler that goes down to the bottom of the ocean and scoops up some sediment so you can see what's on the bottom of the ocean. This is an example of what we got, straight from the bottom. So tons of shells. Lots of these clams and mussels and things are living on the bottom of the ocean in this environment. So it tells you about the environment and what can live there. Here's another beautiful example, one of my favorite sediments. So another example that would form limestone is a coral reef. So here we have all these corals encrusting, and if this was buried under other layers of sediment, it could eventually make a limestone layer in the crust. So here's an example of that. If you go to the Florida Keys, you can visit a place called Windley Key Geological State Park. And here we have these vertical lines that look really strange. This is where the rock was originally drilled, and they put tiny bits of dynamite in there so that the rock would actually crack into these like big cubes. And then they would crack that into bricks and make these really cool looking bricks with all this limestone, with all these shells and corals and things in them. And this is what a lot of historic buildings in Miami are made out of. So here we've got one of these corals right in the middle here. Here's a close-up of it. So you can see this is a big coral fossil in here. So this is just a preserved coral reef. So you can learn a lot about ancient environments this way. Coal is another example of a biological chemical rock. On the left, we've got these layers showing mud and sandstone, mudstone and sandstone, and the black layer is coal, and you can see it in this person's hand here. So coal is actually formed from plant material that was buried between the rocks and kind of cooked underground a little bit and changed into coal. So it's almost completely made of carbon and it's made of ancient plant material, usually like swamps, like ancient forests, and sometimes like flooded forests along rivers. So this is preserving a different type of environment. And then one of the weirdest examples of a biochemical sedimentary rock that I've seen is a few years ago, they actually found an amber. So amber is an example of a chemical biological rock. This is actually made from fossilized tree sap dripping down a tree. So that's why amber sometimes has little bugs in it. You can see some in here. But this particular amber had a tail in it and it ended up being a tail of a dinosaur. And this is one of the best pieces of evidence that dinosaurs, a lot of the dinosaurs actually probably had feathers. You can see some preserved feathers in here. In this sample, like right here is a feather you can see really easily. And they did an x-ray on it and it actually has vertebrae in here, just like a cat's tail. So it's not a bird, it's something in between, like a dinosaur and a bird. So anyways, that's my kind of crash course on some examples of sedimentary rocks. I hope that you enjoyed it. I am going to sign off now. Thanks.